What is the difference between exponential growth and exponential decay? Exponential growth is when you multiply each term by the same amount to produce another term. The term is always increasing, producing a graph that increases at a constant rate, meaning when the independent variable is increasing by a constant amount, the dependent variable will have an increase by a common factor. This is what a graph of exponential growth looks like. The equation for exponential growth is y equals to a times 1 plus b to the power of x, where y is the final amount remaining over a period of time, a is the original amount, 1 plus b is the growth factor, in which b is the percent change in decimal form, and x is the time. Exponential decay is when you multiply each term with the number between 0 and 1 to get another term. This term produces a graph that decreases at a constant rate. For an exponential decay, the independent variable increases by a constant amount. The dependent variable decreases by a common factor. Here's what a graph of exponential decay looks like. Exponential decay's equation is y equals to a times 1 minus b to the power of x, where y is the final amount remaining over a period of time, a is the original amount, 1 minus b is the decay factor, in which b is the percent decrease in decimal form, and x is the time. Properties of exponentials, word problems. Example 1. A fully charged cell phone battery loses 2% of its charge every day. The first part is asking us to determine an equation that models the percent change C that remains in the battery after t days. Now, as this is an example of exponential decay, we're going to use the equation y equals to a times 1 minus b to the power of x. Now we know 100 is the original amount, and 2% is the exponential decay in decimal form, and we don't know the time. So the equation is c of t equals to 100 times 0.98 to the power of t. The second part of this question asks us to determine the percent change remaining in the battery after 25 days and 75 days. Now, how we find this is by subbing in the number for t. For 25 days, we get 60% of charge remaining. For 75 days, we get a 22% charge remaining. Example 2. A radioactive substance decays exponentially. The present P of the substance that remains after t years is represented by the function P of t equals to 100 times 2.3 to the power of negative t. Now the question is asking us to determine the percent of the substance that remains after 4 years. How we do this is subbing in 4 for t. So P of t equals to 100 times 2.3 to the power of negative 4, which equals to 3.57. Therefore, the percent of the substance that remains after 4 years is 3.6%.